Hello. Hello and welcome to a series of tutorials which comprise an introduction to software for robotics. My name is Marco Coberna. I'm a PhD student at Lund University. I work at the control department and I obviously work in robotics. In these series of tutorials we'll cover the basic building blocks of the bedrock of the software stack commonly found in robotics, and then we'll cover the library I wrote for robotic control, which I think is particularly well suited for beginners. That will get you, up to speed as fast as possible to run something on the robot, so that you have some motivation to explore this further. The intended audience are mechanics, master level mechanics students at Lund University, and they take projects with me. I've noticed that there's a sort of that it would be very good, profitable for both me and for them to have a comprehensive introduction to the software, and then to my software as well. Now I'm releasing this sort of publicly in hopes that someone else finds it interesting as well. And in a more general sense, the intended audience are sort of people who already have some experience with programming, just not in Python, and it's not some advanced level programming. So you basically took an introductory course, and that's about it. But simultaneously, you do know some mathematics that will be relevant for the library that I'm introducing later. So linear algebra, calculus, stuff like this. Those are sort of the requirements, and that you are interested in learning more about robotics. That would also be a good requirement to have. Okay. So there already exists a bunch of tutorials on these topics, well, except for my library, but I'm doing all of them sort of at once. And why do we need yet another one? The idea that I have here is to essentially speed run through all of these topics as quickly as possible, and letting you know where to find the rest of the information. I found that if someone doesn't really know what's out there, it's very difficult for them to find it and learn it. But if I just sort of expose you to the concepts that exist, show you like a small example, I think that will be very helpful. A very helpful first step in building your knowledge further. Now this is like a heterogeneous set of topics. I did my best to make these videos separable, so that if you are familiar with something, you can just click on that video. Although I will recommend that you watch everything, because despite my best efforts and intentions, I don't think I'm capable of perfectly separating all of these out, and I will sort of randomly drop in some piece of a nugget of knowledge here and there. So if you want to be sure that you've covered all the bases, then please watch everything. Okay, and now let's get a bit into the details, into the weeds. What we'll be specifically covering. So as I mentioned, we begin with Linux. I'll talk a bit. In general, I'll try to provide the sort of the context and the reasoning of why a particular choice has been made. I've also, for myself at least, I've found it helpful that if I know why something is the way it is, that or at least some context for it, how it compares to other things, that it's sort of it's more easier. It creates like a shelf I can put the rest of the knowledge on. So I'll try to give you some context as well. Okay, then I'll first talk a bit, in the following video, I'll talk a bit about why are we even doing Linux, why is this a requirement. As a sort of a bonus video, I'll explain a bit how you can use Linux for other things other than just running the library at the end. We'll go over some basic terminology, because it is, if you're a Windows user, for example, there is like some differences on a high level differences on how things are done. So we'll go over that. Then of course we'll do some of the basic terminal commands, stuff like that, just enough so that you can, download the package. The ideal goal for me here is that you can browse the web, browse GitHub, find something that, I don't know, in computer vision that you find interesting, and that you know enough of the starting steps to download and run this code. Like that would be the goal here. And then I'll just because I'm a Linux evangelist, I won't hide it. I'll hide it a bit, but I can't do it all the time. So I've included sort of a bonus video with like a bit of the not necessarily advanced things, but things that aren't essential, but I do think that are, if you just add this, then 1 + 1 will be like 4 or 5 or something. So I did that a bit of the bonus content here. The next topic will be Python. Now again, I am assuming that you do know some programming, and that I don't have to explain what a variable is and stuff like this. If it is the case that you really don't feel secure in your programming, I would refer you to some other introductory material, an introductory course, preferably in Python, and then maybe just come here for a refresher later. We'll basically just cover the syntax as quickly as possible. I will try to give examples of these various syntactic things that are offered, and within this I also include the standard library that Python offers. The things that aren't buried in essentials, I will just sort of mention and refer you to another resource where you can look up more. But again, the idea is that you know what's out there, what's possible, and then if you feel so inclined, you can go and check it out. After covering just Python itself, we'll go into some very common packages, especially the ones that we need in robotics. So that will be NumPy, SciPy, Matplotlib. That will basically cover your mathematical needs plus the plotting of this math. And sort of as a bonus, we'll cover some other noteworthy packages. So things like PyTorch, YOLO V8, stuff like this, just so that it's out there. And finally, we'll go over the library that I've developed for robotics, for robotic control. In particular, at this stage, it's just the simplest possible way to control universal robots UR5E ARM. There's a expanding this, rewriting it to C++ with Python bindings, etc. That's all sort of in the works. So depending on when you see this, that will or won't exist yet. But anyway, the idea behind this library is that it's sort of optimized for the intended audience I mentioned earlier. So you know some sort of bachelor level mathematics. You are taking a course or reading a book or something on robotics, so that you know what homogeneous transformation matrices are, about forward and inverse kinematics, basically up to this level is sort of what we're using. Then we'll cover Docker, because I shipped the library via Docker. I think this is by far the easiest way to get it installed. Now, of course, you don't have to do it that way, but this is what I recommend. Then we'll cover the library itself, sort of what it comprises. Now, if you've heard of ROS, it doesn't use any ROS. You don't have to install that. It's sort of ROS is an alternative to what I have here, where my version is essentially everything stripped down to the bone. Just sort of the thinnest possible wrapper around the commands you send to the robot, and then a bunch of examples of control loops that you send to the robot. So the idea is the least amount of fluff, no sort of abstract classes, stuff like this, or at least they're kept to a minimum. And then you can actually see the line of math that comprises your control loop. So if you know what you're doing on paper, in math, it should be, I'm minimizing the time it takes you for you to implement this. in code, and then you can run it in simulation or on the real robot. I'll cover a bit of the libraries that I use to do this, as I lean quite heavily on them. And then finally, we'll look over some examples in detail, and I think I'll include like an example of how do you start from, you have an idea of what kind of a control loop you want to write, and then we'll just implement it from scratch within the library. Okay, so again, these series of tutorials will be on Linux, Python, and this library for robot control. You can feel free to watch whatever you feel like would be most profitable for you. And with this, I wish you some happy learning with